When we start talking about materials that are going to reduce our future risk with our bulk fillable light cured composites, this is a material that really has gotten my attention. So this is a bulk injectable composite. It's got a really nice viscosity. It handles beautifully. What I really like is that it adapts very well to the walls and to the cavo surface margins, and it is a bulk fill material, which can be a time-saving factor. There's some really interesting things about this material, and that is that it is a very high density resin that is now covered completely with this silane coating. And what that creates is this really homogeneous matrix of nanoparticles, which allows for great polishability while still allowing for really high strength and low shrinkage, as well as good adaptation to the proximal box. So let's talk about this in a little bit more detail. So first, one of the nice things is it doesn't tend to stick to the instrument. It has a really nice radio opacity, so it's easy to identify on radiographs. It's got a nice viscosity, but it also is thixotropic, meaning that we have some shapeability. It's very, very easy to manipulate once you put it in, especially when you compare it to other flowable materials. It has a depth of cure of 4 millimeters, and you can confidently do that 1 millimeter away from the tooth up to about 5 millimeters. I'd be very, very leery of going beyond that 1 millimeter away from the tooth. So if your proximal box is deeper than 4 millimeters, I wouldn't do it. I'd also be very, very careful about what many manufacturers say with 6 and 7 millimeter depth of cure, because that also doesn't account for things like angulation, undercut, and many other issues that lead to poor photopolymerization. So, but for many cases, this means that there's a one-step filling process, and we do get really nice adaptation to the cavity. But it's not that I'm just going to take someone's word for it. As I said, very often as part of the Catapult group and testing products for many of the manufacturers that are out there, I want to try this out for myself. I want to see what this looks like when the rubber meets the road. So when we got the literature at first, I did read all about it, seeing that it was a high-density resin, very interestingly covered with a full silane coating. That allowed the silane particles to disperse. We had a very homogeneous mix, very high-density mix. So it gave us a nice combination of both strength, wear resistance, and improved handling. So again, that's what they wrote, but was it really going to perform that way? It has very good flexural strength and good gloss retention. Why? What is the difference between a nanoparticle filler and a large filler is that when we get a break at the surface or breakdown at the surface, when a large particle filler falls out or breaks away, chips away, that leaves more surface roughness and will have less gloss and a higher likelihood both for plaque retention and for loss of polish and surface roughness to the tooth as well. Certainly better marginal integrity. When we look at this product, we have to talk about strength and wear resistance because of those smaller particles that are encased in that silane coating, and they're very evenly dispersed, so any small breakdowns at the margin typically are still going to leave you with a very resistant and very polishable surface. So you can take a look at these graphs comparing to many of the other materials that are out there with a lower risk of chipping or fracture, also providing a very high and durable restoration.